All right, so we finished letter C. Moving on to the final method here, we're going to use our calculator, all right, to check. So here's the deal with that. If it's a smaller type, like the type we've been working on, a 2x2, you have to be able to follow these directions, all right? I'm going to tell you what method to use, what directions to use. You have to be able to follow those directions if you want credit for that on the next test, all right? If it's a larger type matrix, like a 3x3 or even a 4x4, then I will allow you to go ahead and just straight up use your calculator. You can always use your calculator though to check any of these. All right, so let's see how we can use our calculator, and let's wrap up example number 2. All right, finishing up example 2, letter D. I'm going to show you how to use your graphing calculator to come up with the inverse of any matrix if it's possible to do so. All right. So the first thing we have to do is enter in our given matrix. So our given matrix can be entered in by doing what? Second X inverse to go to your matrix menu. Go to edit. Make sure it's a 2x2 size. And then our entry should be 1, -2, -1, 3. And at this point, go ahead and hit second mode to quit out of that. And now what you're going to do is hit second X inverse again to go to your matrix menu. Select the matrix you want to invert, which is matrix A. And now all you have to do at this point is hit this button. This will invert the given matrix. So it should look like this now on your screen. Hit enter. If it is invertible, the result will appear in front of you. That's all there is to it. So all we have to do now is copy this down on our paper, and we're good to go. Okay, in example number 3, we're going to continue to use the determinant to come up with the inverse, if it's possible to do so, of these given matrices. So for letter A, if the inverse of matrix A exists, then using the determinant method, we would come up with what? A times D, that's 2 times 4, minus what? Here's a good thing to do. Think of like a ribbon. You see ribbons in a lot of places. I like to go like this. That'll help me remember. Or a Jesus fish, perhaps. That'll help me remember how to come up with the determinant. That's what I'm showing you. So it's first 2 times 4 minus a -4 times a -2. Okay? And then we would actually multiply this by what? We would interchange the A and the D terms to give us that, then make the B and the C terms the opposite, which would give us this. Now note, in this particular case, what's happening in this denominator, which again, folks, this denominator is the determinant. It's really the determining factor of whether or not you're actually going to be able to come up with an inverse. So in this case, 8 minus 8, 8 minus 8 is 0. Therefore, the inverse of matrix A does not exist. And we would call this matrix A then, the given matrix, we would call this now what? A singular matrix, all right? Because it's not invertible, all right? Let's do letter B. So, if the inverse of matrix B exists, and we have to use the determinant to figure it out, then we would show this work. Again, the work is important here. So again, I'm going to use my ribbon or Jesus fish here to come up with the determinant in the denominator. So it's going to be a -2 times 4 minus what? A -1 times 3. And we're going to multiply that by, interchange the A and the D values. So we get a 4 here, -2 here, and then make the B and the C terms, the B and the C entries, the opposite of what they were, which would give us this. All right, looks like we will have an inverse in this particular case. Let's see what happens. So we get what here? -8 plus 3, -8 plus 3, which is what? -5. And let's rewrite this. And so all we have to do now is remember scalar multiplication and in essence distribute this -1/5 through every single entry inside of this matrix. So our final result there, the inverse of matrix B would be what? -4/5. And then -1/5. And then what? Ooh, a +3/5. And then finally a -1/5 times a negative deuce would be a +2/5. That's it. There's your inverse of matrix B using the determinant method. Okay, example number 4. This is a beast. Okay. Why do I say that? Well, here's why. So if I'm going to follow these directions, what I would really be doing is this. I would really be rewriting matrix A like this. Geez. And then adjoining it with what? With the identity matrix. And then I'd be using Gauss-Jordan elimination method to yield this new matrix, where again, this entire identity matrix would move from the back to the front, and whatever I ended up with here in this 3x3 area, that would be representative of my A inverse. So let me actually show you all the work involved with this. This is all the work to come up with the inverse of matrix A based upon us being given this 3x3 square matrix A. So you can see it's not necessarily fun, okay? But it does work, and it would generate the inverse of matrix A. With that being said, I will allow you to use your calculator from the get-go, right out of the gate, if you have a 3x3 square matrix or larger size. Just use your calculator to determine its inverse, all right? So with that being said, go back to this example. All we're gonna do is this. We're going to, let's zoom in. We're going to enter in our matrix. So we go to second matrix, edit. We want it to be a 3x3 size. Let's go ahead and enter in the entry. So 5, 7, 4, 3, -1, 3, 6, 7, 5. Lock it in. And then quit out of it. Go back to your matrix menu, select matrix A, and then do what? We talked about this already. This button right here. Just hit X inverse. You should now see that on your screen. Now hit enter, and there's your answer. So A inverse is equal to this. Example number 5. This is the largest one we've seen yet. This is a 4x4 size, all right? We can come up with this matrix by using our calculator, all right? Like I just stated a little bit ago. Okay, so here's how to do it. I'm gonna zoom in, you're not gonna be able to see that in a minute. I want you to enter in these entries into your graphing calculator now. It should look like this. Second matrix, go to edit. It's a 4x4. 1, 2, 0, 3, 0, 1, 1, 1, 0, 1, 0, 1, and then 1, 2, 0, 2. Check those entries. I think they look fine. Now we do second quit. Go back to matrix menu, hit your inverse button, hit enter, and there it is. This is the inverse of matrix A. So all you would do now is you take this information and you'd write it down on your test. A inverse equals whatever this is. Got it? Awesome.